Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video I'm going to show on how to answer the questions related to Dalton's law of partial pressure. So for question number 8 in tutorial 5.1, okay, we have two tanks here. Okay, two tanks are connected by a closed valve. Okay, each tank is filled with gas as shown. Okay, we have nitrogen gas in this tank and we have oxygen gas here. Okay, and both tanks are held at the same temperature. When the valve is open, okay, when we open the valve, the gases are allowed to mix. Okay, before the valve is open, we only have oxygen gas here and nitrogen gas here. Okay, but when we open the valve, okay, these two gases are mixed together. Okay, and the volume will change. Okay, at initial, before the valve is open, the volume of this tank is 5 liter, so the partial pressure is 24 atm, the partial pressure for oxygen gas. Okay, for nitrogen gas, the volume is 3 liter. Okay, the volume of container is 3 liter, so the partial pressure of nitrogen gas is 32 atm. Okay, so we have learned about Boyle's law. Okay, Boyle's law is the relationship between pressure and volume. So P is pressure of gas is inversely proportional to the volume. Okay, at constant temperature and number of mole. Okay, so in order to calculate the partial pressure of each gas after the valve is open, okay, we know that when the valve is open, the partial pressure of oxygen gas and nitrogen gas will change. Okay, so how to calculate? We are going to use Boyle's law. Okay, formula of Boyle's law. So first we calculate the pressure for nitrogen gas first. So we use the formula of Boyle's law. So P1 is the initial pressure, 32 atm, and the initial volume is 3 liter. Okay, so we want to calculate the pressure after the valve is open, so it means P2. Okay, after the valve is open, the volume change from 3 liter to 8 liter. Okay, 3 plus 5. Okay, 8 liter. So the partial pressure of nitrogen gas after the valve is open, or P2, is equal to 12 atm. Okay, this one for nitrogen gas. So for oxygen gas, okay, same method. So we use P1 V1 equal to P2 V2. So the partial pressure for oxygen gas before the valve is open is 24 atm. The volume is 5 liter. Okay, we want to calculate P2, the pressure after the valve is open, and the volume is still 8.0 liter. So P2 is equal to 15 atm. Okay, and then B, calculate the total pressure. So A, just now we use Boyle's law. Okay, the pressure change when the volume is changed. Okay, for B, to calculate the total pressure, here we use the concept of Dalton's law of partial pressure. Okay, Dalton's law of partial pressure states that the total pressure of a mixture of non-reacting gases is equal to the sum of the pressures that each gas would exert if it were present alone. So in this case, we have gas, oxygen gas and nitrogen gas. Okay, so the P total is equal to the sum of partial pressure of nitrogen gas and partial pressure of oxygen gas. So the partial pressure of nitrogen gas is 12 atm and oxygen gas is 15 atm. So the total is 27 atm. For question C, we want to calculate the mole fraction of each gas in the mixture. Okay, what is mole fraction? Mole fraction, okay, let's say mole fraction of nitrogen gas means number of mole of nitrogen gas over number of mole total, means number of mole of oxygen gas and nitrogen gas. But in this case, we don't have the number of mole of each gases, but we have the total pressure and the partial pressure of each gas. So we can use the formula of mole fraction. Mole fraction of nitrogen gas equals partial pressure of nitrogen gas over P total. So partial pressure of nitrogen gas is 12 atm. P total is 27 atm. So the mole fraction for nitrogen gas is 0.44. Okay, we cancel out the unit atm, so mole fraction that does not have a unit. Okay, for mole fraction of oxygen gas, so partial pressure of oxygen gas divided by P total, so 15 atm divided by 27 atm, so the mole fraction is 0.56, no unit. Okay, cancel the unit of atm. Okay, that's all for Dalton's law of partial pressure. Thank you.